Coach Mixon, you're muted.
Thank you for whoever told me that, so I don't spend the whole 30 minutes just talking to myself. Can y'all hear me now? Can somebody tell me if they can hear me?
We can
Yeah, I got you.
All right, so if you're joining, if you hadn't caught every lesson, try to catch up on our website. All this information that I'm sharing with you guys is listed. You have to read it yourself, or there are YouTube videos. Most of them are up. Some of them didn't record on Zoom. So just have to catch up when you can, okay? So we've talked about the muscles, and we talked about what's inside the muscle and how it works, and what its main job is to basically shorten. And then we've talked about the energy systems and how your body is like a hybrid car and it runs on 3 different energy systems. And your muscles are provided fuel through ATP. And there's 3 different systems that generate that ATP. So now we're going to kind of go back into the muscle part, which is kind of going to explain. I think this kind of starts to explain why some swimmers are, really good at certain events and some at other events, and what your body is doing when you're swimming and what's going on in your body. So we're going to talk about our muscles. So every muscle in your body is made with tons of cells, tons of fibers. So there's a lot of fibers in your muscles, and they're not all equal. So we're going to talk about what is the makeup of what's happening in that muscle. Okay, so what's the difference between a sprinter and a miler? When you say that, and I say not people that are age groupers, we're talking pro level athletes, sprinter versus miler, Caleb Dressel versus, Ledecky on that scale. Okay, so not just because you think you're a miler or whatever. So what happens fast twitch versus slow twitch muscles? That's what we're going to be talking about in this section. Okay, so just to review from the first top, I'm going to zoom in here as we can see. This is what's happening inside of your muscle. These thin filaments, those are, as I explained in lesson 1, those are like the lane ropes, the actin. And then the myosin heads and the myosin are our little swimmer is the myosin, and their myosin head is them pulling on the lane rope. And what they're doing when they're pulling on that lane rope is they're bringing the muscle closer together, okay? So it's important to know that myosin head is the little things that look like caterpillar feet, and then the myosin is actually like the little caterpillar in the middle, okay? So that's what you need to know. And then second thing that from the energy systems that will kind of go into play here that we talked about is the glycolysis system uses sugar. As we see here, sugar comes in as the fuel, and then the aerobic system, which happens inside the mitochondria, and there's the Krebs cycle that happens in there that's super complicated, but fat comes in as the fuel source. Both of those things produce ATP that goes to the muscle. Okay, so we need to know that. It's hybrid system, and not the thing about it is that not all myosin heads, and those are these little things inside of your muscle right here, these little caterpillar feet that pull the muscles close together and further apart. Not all those little myosin heads are the same. And different muscle fibers get most of the energy from different engines because there are 2 main engines that we're using mainly when we're swimming, the glycolysis and the aerobic, and they're using different fuels to burn. Okay, so we're talking about 2 different muscle. We're gonna break it down into 2 different muscle types. Okay, fast twitch fibers and slow twitch fibers, and those fibers are inside your muscle. Okay, so this is what a fast twitch muscle or fiber would do. They lift more heavy stuff and for a short amount of time. Okay, so short amount of time, heavy stuff, you're using fast twitch muscles, and your myosin head is bigger. Greater. If you look at how it's really purple there, it's thick. It's like this heavy myosin, and it's thicker. And you have less mitochondria. You're using sugar, and we wanted to think about that. And I'll explain it a little bit as we go. Is the white meat on chicken? Okay, so the white meat on chicken, and you see the power graph is big with fast twitch, but the time is not, and that kind of goes back to what we talked about before. You got a lot of power with those fast twitch muscles, but then you really don't have a lot of time. Okay, so your slow twitch fibers or your fibers and to make up the slow twitch, they can move light stuff for a long amount of time. Okay, and you see that they're a little smaller as they're in blue and not as thick and big, and those myosin heads aren't quite as strong. There's a lot of mitochondria, and they use fat and oxygen, and you want to think about that as the dark meat on chicken. So like we'll explain again about what that means later. But the time duration for those that use those slow twitch fibers, and that when those fibers make up mainly slow twitch muscle, the duration you can use them. So there's three main factors that determine what kind of muscle fiber you have, okay? And that's the type of myosin head you have, the major energy system used, and what fuel is stored. So inside of your muscles are smart. They store the energy they need, whether that be sugar or fat, based on if it's a fast twitch or slow twitch. So the things that determine what kind of muscle fiber would be the myosin head, the energy system, and the fuel, okay? And then we're going to look at each part of muscle fiber like pieces of puzzle, starting with the myosin heads. The heads are these little guys that attach to the lane rope. So this is happening inside of these fibers that make up your muscles. Okay, and again, the job is for them to shorten, to pull the two walls, the two black lines. If there was another black line over here, it would be pull it together. Okay, so fast twitch fibers. Again, there's a lot of fibers inside of each muscle. These fast twitch fibers, okay, focus on shorten quickly with a lot of force, but they don't last a little long. And the deal is they burn a lot of ATP. So these fibers focus on developing myosin heads that burn through ATP at a huge rate. So it allows the muscle to shorten at maximum speed and power. This is great for sprinting. So if you got a lot of these, we'll talk about it again, how it compares to your race. You got a lot of these in your system, you can be better at sprinting. So if this produces a lot of ATP quickly, but it's great for maximum power, but it doesn't last. Slow twitch fibers. So these fibers that are inside of your muscle that are slow twitch, focus on shortening slowly with very little force, but the myosin heads use up ATP, so they use up energy slowly, and they can maintain their contraction for a long time. So perfect for a mile. Okay, so if you notice right here, this would be lifting 10 pounds for a long amount of time. Okay, this would be what a slow twitch would look like, and you see it's just using a little ATP, a little energy. This would be an example of a slow twitch, and then this would be an example of a fast twitch. You see how it's thick, moving a lot of weight, but it's also using a lot of energy, and that energy, again, after it's left over, it's turning into ADP. So this is slow twitch, this is fastest, okay? So, and that's all happening inside of a muscle. So it'd be really easy to think about it as two extreme types of myosin heads, slow and fast, but really there's a whole spectrum. So that it doesn't have to be completely slow or completely fast, and that's what this is saying right here. There's a whole spectrum of myosin heads that lie in between extremes of fast and slow. So you could have like a medium speed myosin head, and not necessarily have extreme fast or extreme slow. So there, on top of that, inside each muscle cell, there is a combination of different myosin heads. So you could have some fast and some slow, so that you have a combination of those myosin heads inside each muscle cell. So there are many different factors that explains why there is a difference between sprinters and milers. Okay, so this is an example on the far left. This is an example of a muscle with all fast myosin heads, so all fast twitch fibers. You can see how thick they are and strong they are. Okay, and this is an example of all, on the far right, of all slow myosin heads. So if the muscle fibers all just slow in there. Okay, and then this is an example of a mixture in the middle. Okay, you see that's what it's saying here. All fast twitch, all slow twitch, single muscle with a spectrum. So the muscle has a mixed, okay? A muscle has the mixed of fast and slow. Okay, so it's important to know that the different muscle types use ATP at different rates. It becomes important for the muscle cells to modify its energy systems in order to keep up with the ATP demand and be efficient as possible. So the glycolysis system, which is also part of the aerobic system, uses sugar, but it uses ATP quickly, and it has produced lactic acid. And again, that's kind of a review. The aerobic system uses mitochondria, and it's at a slower rate. And this is kind of review from last time. Glycolysis system uses sugar, 30 to 40 minutes. You have lactate as the byproduct. You're not using oxygen, and it's trainable through sprinting. And then your aerobic system, you're using fat and pyruvate. At duration, it lasts forever. The byproducts, CO2, H2O, and you're using oxygen, and you got a lot of distance. Again, fast twitch muscles burn a lot of ATP quickly. It needs to replace fast. That's why fast twitch muscles have a very developed glycolysis system. Okay, so that's important. Because fast twitch fibers rely mostly on glycolysis, which is the use of sugar, they have a tendency to overload themselves with lactic acid quickly, otherwise than fatiguing. Ever wonder why those lazy sprinters need so much rest after doing a 25? Okay, and that's like, you know, we're talking pro athletes. What happens is they're using the glycolysis system for that energy in those sprints, which also the byproduct is the lactate, and then that's why they have to take a lot. Slow twitch fibers don't use as much ATP. They can rely on slower and more efficient aerobic system. This means slow twitch fibers have many mitochondria. And again, you're going to see this mitochondria word a lot. It's important. Also larger than normal. Okay, so fast twitch using sugar. Okay, small mitochondria producing a lot of ATP. This is what the muscle fibers would look like on a fast twitch cycle. Slow twitch cycle, aerobic, use it with big mitochondria, and then this is what inside of the muscle fibers would look like with smaller myosin heads, bigger, fatter myosin heads. Okay, so we've talked about the machinery injury system, energy systems between fast and slow twitch fibers. Now we need to understand the difference between the white and dark meat chicken. Okay, so yes, you do have white and dark meat chicken. If you don't eat chicken a lot, you should know that. Since different energy systems are used to fuel those muscles, that's important. Okay, so different energy are used to fuel your fast twitch muscles fibers and your slow twitch. Okay, fast twitch use mainly glycosis, which is sugar again, and there's less fat inside the muscle. So if you think right here, if you think, I like this analogy that he's about to give down here of a chicken breast, okay? This is the white meat, okay? Stored sugar, water takes up space, limited on how much it can store. These sugar, they run out of energy or sugar in about 30 minutes. And that's why sprinters have trouble going fast at the end of the workout, okay? Because they run out. Slow twitch fibers, they use a mitochondria for the energy, which uses a lot of fat. These fibers have high stores of fat inside the cell. So again, I mentioned earlier that your muscles store this energy in there automatically. And so during your slow twitch fibers, it's storing fat, and then your fast twitch fibers, it's storing more sugar and water, okay? And you do have a myoglobin. It's kind of like hemoglobin that's also stored, and it's in your system, and then it gives it the red color like hemoglobin does in your thing, and that's why dark meat is dark, okay? And that's why dark meat, like why your blood is red, is because of the hemoglobin. Why dark meat is because this myoglobin is oxygen that's stored in there, and it causes the fibers to be dark, a darker color. Okay, so I like this analogy for all that long talk. If you think about the parts of the chicken that are dark or white meat, it makes sense. The breast meat of the chicken doesn't do much. At best, it can fly about 10 feet. The legs, however, chicken, which I like the legs, run around, and they're constantly working all day, and that's why they're dark meat, and they contain lots of myoglobin, and they're also full of fat. Okay, so if you deal with chicken meat a lot, the darker meat is a little fattier. It's dark, and that's usually because that's a slow twitch muscle. Has more slow twitch muscle fibers, and they run around on those little legs all day. They use the breast. It's just sitting there all big, and they only use that breast to fly, and it's really more short fibers in there. Okay, so that's what's going on with that. And this talks about the myosin heads use fuel storage. Okay, we're going to skip through that a little bit. So you see here, this is fast fibers, again, using the sugar system. Or the slow fibers are using the aerobic. That's all that scale is showing. So here's the deal. Most people on a large scale, on a spectrum, this would be a sprinter would have mostly fast fibers inside of some muscles, okay? So sprinters here, this is a professional sprinter. This is a professional distance swimmer would have more slow twitch, okay? And then most of your people, that's a miler, I'm sorry, this is your miler. And then most people are going to fall in this category. Most humans are going to have a scale, okay, of a number of fast and slow twitch. So that's what you need to know is, and we're going to not keep you all night, so I'll break the other part into another session. I know that you're thankful for that. Okay. So this is the deal. When you fall on the spectrum of fast or slow fibers, it's mostly based on genetics and it's present at a young age. With training, a single muscle fiber can slide along the scale, but it can never totally change, okay? And so we'll learn how to train it so it gets faster. So most people are born genetically, and we're going to talk in this next session about each fiber, but most people are born genetically with inside each muscle fiber either an equal amount or proportional amount. That's this, where they have some slow, some fast, say 5 and 5 of each, just to throw that out there. And then we're seeing where milers in their slow twitch fibers in their muscle, they're going to have more slow twitch fibers, and they're just born with that genetically. And then your sprinters are going to, and their muscle fibers are going to be made up of more fast twitch fibers. And that's why it makes them better. And then this is how you train it. You can see with sprint training, the dotted line, you can elevate there, and the total shift is not possible. So you really can't take somebody who's born with all fast and make a total switch, but you can make it better. Okay, so that's the key, is you can train the systems, and that's what we're going to look at next. And again, this kind of goes back to that. A pro swimmer, just say they have one slow twitch fiber right here inside, whereas a pro miler may have all these slow twitch and one fast twitch fiber inside of a muscle makeup. And that's what makes somebody a pro miler versus a pro swimmer. And a lot of that is to do with genetics, but we can train it some, okay? So that's where I'm going to stop today. We'll start off with the next time. So kind of a lot of it was a review. Just you need to relate fast twitch muscles with the glycolysis system, and they use sugar. Slow twitch muscles with the more of the aerobic system, and they use mitochondria. And notice that the myosin heads are bigger and more aggressive on the fast twitch, and smaller and thinner on the slow twitch. Okay, so that's kind of where we're at tonight, and we'll leave it at there. Again, I hope I didn't kill you with boredom. My voice is tired because I did all that trivia. But thanks for coming in. I'll do the last part probably later this week or at the beginning of next week. Okay, and you can always read ahead. Thank you guys for tuning in. I'm going to tune out. See ya.
Thank you.
Bye, Nixon.
Bye.